Hello YouTube, De-bodgery here. Welcome to EV Components Review. On the bench is the macro view for the Votol EM-150 controller. Thank you, Mike, from evperformance.nl. He is in the Netherlands, the country, and he sent this to me all the way from over there to do a teardown on it. Yeah, Votol I would have never expected was as good as it is, but in fact it's pretty darn good. With some exceptions. So anyway, let's get into this thing and see what we can find. So right there is our main DC to DC buck chip, and that guy is a SD4938. It's a 150 volt DC to DC converter. The manufacturer is a company called Surron, and they call it a 150 volt current mode PWM controller. That means buck. So step down converter basically. Right here is the inductor for it, and here's its main capacitor for DC bus filtering or battery bus filtering, and probably one of these other two little capacitors right there are the other side of that for the other side of the buck chip. But anyway, yeah, that's how you get battery voltage and drop it down to 12 volts. I mentioned in my previous video, the overview, that there was a 6-volt linear regulator. Well, there you go. 7806, that's it right there. I have yet to run into some other controller that needed 6 volts. Most of them are 5 volts, so that one was kind of interesting. This little part right here, this is an 1117 linear regulator, and specifically a 3.3 volt one. If you could see the top of that or that linear regulator, yeah, it's really obscured, but right there it says 3.3. And across the top right here it says AMS 1117. Anyway, it's a very commonly used part for small current linear regulation for things like, say, CPUs. Right here you can see all these little small components right there. These are a special kind of a diode, and when their voltage is exceeded they become a dead short. But they reset afterwards, so they don't like burn out per se. They just become a short, and what they'll do is they take over voltage situations and they just basically ground it out. And they go to various input pins off this connector, signals coming back in again. So these are effectively protection devices, so that if something on the outside world going into the controller does something a little bit nasty, these guys would probably try to short that off to battery minus, rather than creeping on inside and like blowing up the processor. So better that these go, or that they just simply stop an overvoltage situation from happening, then you lose your entire controller. Anyway, yeah, kind of glad to see those. What was it? EBMX X9000 has similar parts like that. I forget what else. Let's see. I believe the Surron controller also used these parts. Alright, right here is your CPU, and that's an STM32F103. There are FOC libraries for this processor, but I don't believe that this controller is running them. I believe this is a sinusoidal controller, and I say that for several reasons. Well, first of all, the manufacturer doesn't say it's field-oriented control. You look in the documentation, and it doesn't say anything about it. You look at all the setup pages for the controller, and there's nothing in there that would lend me to believe that this is FOC control. And also, you have just a battery minus shunt, whereas with most FOC controllers, like right here, yeah, so that would be where a phase would connect. You would see current sensing right here, and again, there's nothing there. So there's a pretty good chance that this is doing sinusoidal control and not FOC, which is fine. Okay, right here and here are two identical chips, and those are rail-to-rail op amps. And wherever they are, oh, come on, there it is. So those are SD06s, which is a 6 megahertz rail-to-rail operational amplifier. I think I know what they do, but I can also be wrong. I think that these are measuring something off of the phases And since there's two of those same op amps in each one of them, possibly one of them is amplifying the signal off the shunt before it gets into the processor. But probably my guess is the other three are using this little bit of circuitry right here. So you'll see right here we've got a resistor and a little capacitor, and that's coming right off of this phase bus right here. And it comes back this way. I bet you that whatever signal this is getting amplified or cleaned up by that op amp before it gets back to the processor. That's my theory. I'm willing to be wrong. Probably am. Don't know. All right. Right here. So you've got all these small discrete components. Notice how there's no gate driver IC. It's instead a bunch of discrete components. So this little MOSFET right there that's feeding all of the gates of the larger MOSFETs, which are up here. Realize it's off the screen, but my tripod won't let me move this down anymore. It's in the way. Anyway, this exact circuitry, almost to the exact position of parts and components and everything, is also on the high side. But rather than using a gate driver IC, they did it with all discrete electronics instead. And they also made sure that they had current limiting resistors. So there is one right there, 100, that means 100 ohms. And there's another one, and there's another one, and there's another one. And that goes to all four gates, which would be this leftmost leg on the MOSFET for current limiting into those MOSFETs. So yeah, that's all good to be there. And then everything else here is basically gate drive for the whole bank of them, the four in parallel. All right, let's go to the high side. There we go. There's one of them. So no, that's not one. Where is it? Right there. Yeah, so right there is one of the, I think there was 5 ceramic caps that are doing all the high frequency filtering. Yeah, and they're little dinky things. Yeah, this board definitely needs bigger ceramic caps on here. Anyway, here is the high side drive electronics. It's the same MOSFET, all of those same parts, all the resistors and diodes in here are the same. It's just that this section right here is driving the battery plus side MOSFETs rather than the battery minus side. But it's all the same parts, essentially. You know, like here's 100 ohms, here's 100 ohms, here's one, here's that one, other one. That's all the gate driver current limiting resistors for the 4 MOSFET gates. And since we are looking at this side, you definitely see it's a little bit better. So that's one of the gate legs. Here's the next one, and next one. That's like the light switch lever, if you will, on a light switch. And then across the other 2 legs, that's like the switch contacts. You know, these MOSFETs are doing kind of a similar job. And as you can see, they are magnet chip MDP 10N27s. This is one of my top 2 or 3 MOSFETs, 100 volt MOSFETs in the TO220 package. I was very happy to see them here. That's such an unusual thing that you have a Chinese controller with Western MOSFETs in it. Yeah, that's super cool. All right, the one detail that I said that I didn't like about them is evident. So you can see the MOSFET leg, and it's straight up, and it's on the skinny section that curves over, and the fast section's over here. So this is the full length of the MOSFET leg, and what is soldered down to the board is the skinny part that can only handle 50 amps and not the fat part up here, which can handle 75 amps. So as a result, the legs have a lot more heat in them than they otherwise would if they were soldered down to the fat section of the leg. So yeah, I would definitely like to see that be different. In fact, I'm thinking about upgrading this controller, doing a few mods for it so that it's more powerful. And that's probably one of them I do, is unsolder all the MOSFETs, clean out all the holes, and then shove them in up to the fat portion of the leg so that I'm getting the best case current transfer from the MOSFET to the circuit board with the least amount of heat. Alright, about the only other thing that I want to show you here before we flip this thing over and look at the back side is, wherever it is, yeah, there it is. Yeah, there's the other of the small ceramic capacitors. When I say small, I mean they're little, that do high frequency filtering. It is very cool and satisfying. So here's battery minus bus, and look at this circuit trace, all of the vias in there, and the whole purpose of that thing, because it's not a current carrying path, is to bring battery minus over to this large capacitor. That's really all it does. So yeah, this is serious overkill. Love seeing things like this. Yeah, it's another way that Votol did not back off from the details. It did a pretty darn good job. Yeah, here is battery plus right here. I mean, look at this. It is just row after row after row of vias, which ties all that copper together, creating a much better current path. And then you've got this piece of copper, and yeah, there's that gap I'd like to fill. And if I upgrade the thing, I will fill that. But yeah, lots and lots of copper in here. This is, as far as current carrying and efficiency and losses, this is pretty good. Needs better high frequency filtering. As well, just not enough of those. Back side of the board is the same way. And let's get you to focus. There we go. So one of the things I mentioned was that the copper has like fingers that go down and go right up to the MOSFET legs. And so you can see them. There's one, and there's one, and there's one. And as you can see, they are literally right at the MOSFET leg. Yeah, you can't hardly get a better current path than this. This is stupendously good. And then, of course, this piece right here, that is the phase bus. And you can see a little corner comes out right to the MOSFET leg. Little corner comes out right to the MOSFET leg. Could they have made this a skosh longer and filled that tiny gap? Yes, they could have. Could they have put this little nubbin of copper right up against that MOSFET leg? Well, no, because they're pretty close right there. But could they have done this just a tiny bit better? Sure they could. But is this still really, really good? Oh yeah. Yeah, this is way better than you'll find in any KO Moto controller. That's pretty darn good. And that is all the way down the line. And so this is all battery minus right here that you're looking at. But you can see that for every single of the MOSFETs. So like in the case of this one, this is the large section of copper that comes down from the battery minus bus, and it's still really close to that MOSFET leg. So that is completely acceptable. But as you can see, that is all the way down the line for all those MOSFETs. That is pretty darn good. Yeah, let's look at that too. So here is your battery minus bus soldered right to the shunt, and as you can see, they are touching and they're soldered together. Yeah, this is how everybody should do it. That's excellent. That's not a problem. That is not a current failure situation. This is never going to be an issue. That's probably, oh God, probably at double the wattage or double the amperage of this controller. Still won't get warm. Yeah. And then here is battery minus. And again, this is very good. So, you know, all this copper right here, and this is the other side of that shunt. And as you can see, they are touching and they are soldered together. This is super good. Good job, Votol. You did an excellent job. I wish that the $1,000 controller from KO Moto copied your work because, well, they didn't. And they should do at least as good a job as you did. And Votol is a budget controller. Yeah. And it's better constructed than a $1,000 controller from KO Moto or more. Anyway, that is about the only things I want to show you. Yeah, there's nothing on the bottom of the logic board side of it to really look at, just some circuit traces. And the power stage on here is absolutely epic. I guess I'll talk about this one last thing. So this is battery minus here, and this is battery plus. If I do upgrade this board, I'm going to bridge across here several ceramic caps. Do that in several of those places, and probably just between the two phases here is sufficient. But yeah, put like 3 or 4 of them here and 3 or 4 of them here, and that's going to clean up the high frequency noise that's in here pretty significantly. And do the same thing on this next one too. Put 3 or 4 of them there and 3 or 4 of them there, and that's probably going to take care of any high frequency noise that this bus has to offer. Okay, I think that's everything that I want to show you. If you are looking for a budget controller, you know, something that's less expensive, and you still need decent amounts of wattage, and you want something that's pretty reliable and robust, well, consider buying a Votol controller. I never expected I would say anything like that. I am a diehard FOC fan, and definitely for VESC, definitely a diehard fan for that as well. Yeah, I like FOC controllers. And there's, good brands that have Western parts in them through and through. And here is a Chinese controller that is right up there with those. Yeah, buy a Votol if you need a fairly inexpensive but decent made controller. It's not bad. It's pretty darn good.